All right, folks, very good morning to all of you, and welcome to our 1 hour session on building open source AI agents to automate SDLC. If you are joining us from the patched LinkedIn page, remember this is being broadcast over YouTube. So if you have any questions, please feel free to use the patch YouTube channel chat, and I'll have a look at it as we go along, and happy to address some questions. So in preparation for this, if you we had actually set up a short poll 2 or 3 days ago, and if you were on our page, you might have seen this. So I think the question about was when do you think AI will write 90% of all new code? So this is not code which is already written or code that needs to be maintained. When do you think, as a developer, that AI will be able to write 90% of all new code? And I think the options were A, less than 5 years, B, more than 5 years, and C, never, right? And I saw there were some responses, but what I did is I've also posted this poll on the live chat on YouTube. And as we go along, please feel free to post. But as of when I last checked, I think more than two-thirds of people were of the opinion that AI will be able to write 90% of all new code in less than 5 years, right? So we'll come back to this question perhaps at the end of the presentation, but just keep that in mind. So at least two-thirds of people believe that within the next 5 years, AI will be able to write 90% of all new code. Now, I think you must have seen recently news around Devin and Magic and so on, and a lot of companies coming in this space that are trying to recreate AI software engineer that can code entire projects from a single prompt, right? So you write something, it comes up with a plan, it figures out what to do, it reads documentation, and so on, right? So AI may very well be able to automate software in the next 5 years. But what we are looking for this workshop today, what we're looking at past, that what is it that we can do today, right? So great that in some near future we may be able to automate a large amount of software development. But what is it that we can do today in order to make our lives easier as developers? So there are certainly parts of software development that are usually, more mundane or not so creative, or things that developers do not like to do as much. So I'm talking about things like, running scans, finding vulnerabilities, fixing bugs, maintaining software, creating documentation, doing pull request reviews, and so on. So what we are going to look at today is that are there parts of software development that suck? They feel more like chores instead of some creative way where you're actually building something new? And is it possible to automate those parts and make our lives easier by not doing more of them, right? So, and if you look at how software today is, from a developer's perspective, right? And there's a very nice cartoon comic strip that I have here is like they just sometimes write code and then once it compiles, they're like, hey, done, I finished, I've coded the feature, right? But as most of you know who have been in the industry long enough, that's rarely ever the case, right? So 80% of the work that happens on a particular piece of software starts or is after you actually commit that code in or you do, right? So and these include things like writing unit tests, doing code reviews, managing deck, fixing bugs, and generating documentation, right? So there are a lot of aspects of software development with a more or less laborious, disruptive, and slow. And over the last year and a half, there has been a lot of potential that LLMs and generative AI has shown in order to automate different aspects of SDLC, right? So here are some few examples. Work from Meta, which spoke about how they use large language models to generate unit tests, right? And there's another piece of work here which is on code review and then for automated bug fixing, right? So in the last 1.5 years, all since the start of ChatGPT or GPT-4, we have seen a lot of work in different domains, which suggests that LLMs have a lot of potential to automate different aspects of SDLC, right? And even if you were to do it today, you still need to figure out how exactly to orchestrate this, right? So having a capable large language model that can do parts of it is good, but you still need to do some things around how do you integrate it seamlessly in a developer's workflow? How do you provide context to the model, all the while preserving privacy and flexibility? So not many people want to use the ChatGPT or OpenAI. They want to copy paste their code inside and send it to OpenAI, right? So how is it that we can actually do or automate parts of this in a very easy and flexible manner, right? And as we thought about it, this whole concept of agent came into picture, uh, an which is a autonomous tool which has access to a number of uh, access to memory, can plan, can take certain actions on behalf of the user. So these are like in general AI agents, right? Our framework is actually based on top of it. So what we have done is we've taken aspects of a generative AI based agent architecture and adopted and modified it for managing and maintaining source code, right? So with this, I would like to introduce PatchWork, which is an open source framework that integrates into your SDLC cycle. So you can run it from your IDE, from your command line, inside your CI/CD pipeline, automates your SDLC tasks while giving you complete flexibility and control over which large language model you want to use, which tool you want to orchestrate, where you want to uh, run the workflow, and so on, right? So, so this is kind of how it looks like, right? So at the core of it is a framework, and all of what we do is actually concerned with the SDLC cycle. So in terms of the tools that you can use, we have various scanners, which includes things like static analysis scans, software composition scans. We have access to CI/CD. You can use QA tools. All the actions that we can take using Patchworks are in form of atomic things we call steps. So you can combine existing steps, so you can write your own steps in Python, and then you can use it. The planning part, instead of letting the agent autonomously decide how to fix, because we believe we are not at the place where agents can actually do that, we let the human developer actually come up with these plans in form of various workflows, something we call patch flows, right? And the thing that this agent or patchwork operates on are actually things that you interact every day as a developer. So your source control repository, your issue tracker, your documentation, and so on, right? So this is kind of how it looks like. You can check out it's open source. You can start the repo. On the base, we have the framework, and then we have some set of atomic steps. So by default, you will have around 20 odd different steps, which take care of various aspects of SDLC. So these include things like committing code, creating pull requests, scanning, and so on. And you can actually orchestrate different workflows, which we call patch flows, using these steps, right? And in the app, we also have a GUI-based builder that allows you to assemble and build these patch flows by dragging and dropping steps and editing them and managing the workflow. Okay, so now you may be wondering, like, why do I need another framework? I mean, there are so many different frameworks for using LLM. There's LangChain, there's Lambda Index, or I can actually build my own. Do I really even need a framework like this, right? So I think there are key things to understand. One is that when it comes to building or using code LLMs to do or automate coding related tasks, the benefit of using Patchworks is that it's already integrated with IDE, CLI, and CI and CD. So you don't have to worry, figure out how you're going to execute it within your pipeline or locally. Second benefit is it works with any LLM. So if you have, or if you want to use, you can use a OpenAI's API key. You can use Google Gemini. You can use Claude. You can use any LLM, or you can also use any local LLM. So it will work if you already have deploying on running LLMs in your own infrastructure. You can just use the same, right? So we allow people to bring their own LLM or use their own LLMs. Uh, each step or each workflow that comes in ships with a set of prompts, but you can actually customize and edit those prompt using prompt templates. So if something doesn't work for you, or if your repository is very different, or there is some change, or you want to customize a little bit, so instead of writing code, you can just edit the prompt template file and then make the changes. And finally, it's very easily extensible. So if we don't support some action today, you can easily add another step in the framework using Python or using of a GUI builder, and then you can just combine all of those together again in form of a patch flow that would work. So we believe because of all of these features or capabilities, if you want to build or experiment with the LLMs in your pipeline, you are better off starting off with something like Patched instead of trying to come up with your own framework. So that's the reason why you would choose Patched instead of building your own or using your own. Right. So at this point, I'll just take a pause and I'll just jump directly into the demo. So I'm going to show you both. First, I'll just walk you through a little bit about the open source framework, how it's structured, what are the various parts, and how you can install and run the Patchwork CLI. And I also take you through our application, which is essentially the same thing, but allows you to run patch flows through the app and then gives you a nice GUI for building and executing these patch flows. So let me just pause a little bit here, and then I'm going to switch to the demo. Okay, so hopefully you can see my screen. So on the left, I have the patchwork framework open. So like I mentioned, there are three components. One is the steps, the second is the prompt templates, and finally, what are the workflows that you automate, which we call patch flows. So out of the box, you get five patch flows for various use cases. So the first one is what we call autofix, which can automatically scan and fix vulnerabilities in your source code. The second one is a pull request review workflow. The third one is a documentation generation. We have workflows for dependency, upgrade, and issue resolution, right? So what I'll do very quickly show you what a typical or a simple patch flow might look like, right? So the way it is implemented, uh, for example, autofix, you each patch flow has some set of default configuration where you can decide and choose what you want to do. So it includes things like what model you want to use, what are the settings for the model, what is the context size that you want to give, and some additional steps that are specific to the patch flow. So in this particular case, it is because we use the SemGrep open source version to scan. So there are some arguments that you want to pass. You can actually specify those. You can specify how many vulnerabilities you want to fix, whether you want to filter them for severity, compatibility, and so on, right? So let me just show you very quickly how all of this works on an example repository. So we'll play around with this one particular example. This is a example repository I just spoke from Veracode. So it's a Python repository. There's a single file in here. And as you'll see, when you scan, there is some vulnerability. There is a call to shell directly. We'll try to see first whether we can use Patchwork to automatically fix this vulnerability. So on the right hand side, you'll see my screen. I've cloned this repository here, and I'm now going to try and run patchflow. So the simplest it's way to run it is through the CLI. So you can install the CLI using PyPy, or you can just clone and run it. Once you have it set up, all you need to do is you need to call patchwork, autofix, and then it's some set of configuration, right? So I'm just gonna run it while I talk about what the configs contain. So I mentioned there's already default configurations for each patch flow. All of these are actually, you can either use the ones which are there, or you can take the ones which we have created and made available in a different repository. So if you go here, so these are the configurations which are used to run this particular patch flow. So you can just put all of it in a single repo, and then you can just call it by passing the path to the repo. So you don't have to do it for each patch flow when you're running, right? So that's all that contains. It contains the default YAML file. So you'll notice on the right, so the just printing some information about what are the steps that ran. So for this particular patch flow, you'll see first it did a scan using semgrep to identify the vulnerabilities. Then it extracted the vulnerable code, prepared the prompt by finding the right context, then calling the LLM, and extract the model response, make changes to the code, commit those changes in a new branch, and then push and create a pull request. And if you go here and take a look at the pull request that was created, what we see here is that it has some description which says, hey, this pull request from patched fixes one issue. This is the file that was changed, and there's some summary of what was changed, right? And if you go here to look at the changes, you'll notice that it made some changes to sanitize the and fix the command injection vulnerability, right? Okay, so very similar to this. Now, say we already have this pull request which is open. I want some code review on this pull request. So we can use the PR review patch flow we have. So we go patchwork, PR review, and the configurations are the same, but we need to pass the pull request URL which we want to review. So what we'll do is we'll just take this URL we had and we'll just paste it here. Right. So now in this particular course, as it starts running, you'll see that the first step that was executed is reading PR diff. So it actually pulled the pull request from this URL. It extracted the diffs, it read it, and then it We'll try and summarize what are the changes that are made in this pull request and finally create a comment on the pull request. So if we go down back to our conversation on the left, you'll see that it added a comment here, right? And the comment describes what were the changes that were made, right? Now, similarly, if you notice this file, so let me show you another patch flow, which is on dependency upgrade. So there is a requirement.txt in this file, and there are some Python dependencies. Now we can use patchwork to upgrade them. So here we'll do patchwork dependency upgrade, and I will just run it. What we use for doing dependency analysis, we use this open source OWASP tool called DevScan. So you see that the first step is to scan the repository to figure out all the transitives and direct dependencies that the repository has. Identify out of those dependencies which ones are vulnerable, what are their fixed versions, and then finally prepare a call to LLM to upgrade those versions. So I'll just keep it running. And once it's done, the output is again going to be in the form of a pull request, which will fix or upgrade the libraries in the repository. So you'll notice even in these two runs that several of the steps that you need to do while automating this is actually very common. So if you look at both of these, there's some steps to prepare the prompt, call LLM, extract model response, to interact with the source control repository, to create commits or to read. So that's the reason why having a already well-defined steps library helps, because we've already done all of these tasks. It works out of the box for GitHub. It also works for GitLab. So you don't have to do or code all of these things again and again. You can just rely on what we have. So here you'll notice that it already did the scan, extracted the package manager file, prepared the prompt, and then upgraded the libraries and created a pull request. So now let's take a quick look at this. We'll just go to the pull request. I'll notice that it says, hey, pull request actually fixes two SCA vulnerabilities. The files which was changed was this requirements.test. And we'll see, I think you'll notice that it has bumped up the versions of the libraries. So from request 2.30, it has gone to 3.1, and from PyCrypto 2.4 to 2.6, which contains, which is a fixed version of the library, right? Now, if you want, we can do again the same thing what we did earlier. If you want to take this pull request and ask the PR review patch flow to comment on it, to describe the changes in the pull request, it can do the same. So again, I just passed in the URL. So instead of 39, which was pull request 36, and then I just asked the patchwork to work on this particular pull request and create a comment which describes the changes, right? If you look at it, you'll see the final changes which were just commented now. And it says, hey, the versions of the libraries, these two libraries have been updated in the, so this gives a very summarized description of what are the changes in the repository, right? Okay, now finally, what I'll do is just before I move to the app, maybe I'll just show you one other uh, patch flow. So this particular patch flow is something which attempts to resolve uh, GitHub issues directly, and then given a description of a GitHub issue, try to identify from the source control repository what are the changes or files that need to be changed, and then make those changes and create a pull request. So very similar in style to what you've seen in demos for Devin, which is just start from a GitHub issue and then do everything that is required to fix that issue, and then finally create a pull request that contains the fix, right? So what we'll do is we'll just pass the issue URL, which is which is an open issue in this repository, and run this patch flow. What you'll notice here is that, okay, I misspelled the repository configs. Yeah. So I'll notice that what does the issue say? The issue says that, hey, you need to create a new method in to implement a endpoint slash help, and it should always return okay. So it's in this example app, it's saying that add a health endpoint which returns okay, and the rest of the code should remain the same. We should add the method at the end of the file, right? So this is the description from the issue. So you'll notice here as this runs that what it did first is, first step is actually to embed the repository. So we embed the source code of the repository, and then we'll use the description of the issue to figure out the files that need to be changed in order to resolve this issue from the repository. and then prepare a prompt for the LLM to go ahead and make those changes. So this will take a while to do because it's going to embed the entire repo, then it's going to query it. So I'll just keep it running and come back to it in a second. What I want to show you right now is the prompt templates and how they look like for different kinds of workflows that we have seen. So the first one we saw was this autofix, and I mentioned that there are templates that you can use easily to update. So the templates look something like this. They can be a list of prompts. So what you'll see here is for this, the prompt ID is fixed. There is some description. What to note is that these templates will have some variables which are interpolated during runtime. So they are under these two curly braces. So like message text, and what you'll see here is affected code, right? So the value for this message text and code is actually sent at the point of uh, at the point of execution. So when this is when we execute the patch flow, the affected code is filled up by a previous step, right? And you could have multiple such prompts within the say. So let me just show you one more, which is a dependency upgrade. What you'll notice here is that it has several steps. So it's just not doing a single call with a single LM at one time. So in the dependency upgrade, we have multiple places where we make the call to the LLM in a more agent-like workflow. So you can separate them based on different IDs. So this one does dependency upgrade, and you'll notice it has a prompt which says, hey, update this, make only changes in the dependency file, don't change anything. And then it has a package manager file. Well, there are other two prompts as well, which if you want, you can actually try and assess the impact of the code change. So this one tries to take a diff between the old version of the library and the new one and tries to figure out what are the impacted methods by using the LLM, right? And then finally, the third prompt here is something which will take the old version of the code with a description of what has changed in form of a list of methods and some summary, which came from the previous output. And then it will try to update the content of the code and migrate the code itself, right? So let me just finally show you the resolve review one, which is, sorry, the pull request review, which is something we've been using quite often. So this is the one. So it just says, I said, when you comment on a pull request, it can summarize the diff and then it can make changes to it, right? So these are the prompts for that. Now, let me go back to this. So I think the first step, like I was mentioning, was for it to figure out which file needs to be updated in order to resolve this particular issue. And then it will make the changes in that file. So that's comment saying, hey, the following files may be relevant to issue, and this there is only one file, so there's only one comment. And then it will try and update and fix this issue. So I think it's still running. I'll just go to the one which I already had from a previous run just to show you what it does, right? So what you'll notice that it actually ended up adding another class and added a method in this class to return OK message whenever a request is made to the endpoint, right? So it made the change, right? Now, finally, what we'll do now is we'll switch gears a little bit. Hopefully, you have enough. You've heard enough about the open source framework, so please do give it a try. You can choose and run whichever model you want. You don't have to run our own. You can just decide. So based on which model you use. If you don't want to put in your own key, you can actually sign up on Patched and you can get a free Patched API key and you can use those to run your CLI runs as well. So what I'll do now is I'm going to just expand this a bit and I'll just go and talk about the app. So I have actually logged in. So let me just log out quickly. Right. So this is the patched codes app. You can sign up with your email, or the easiest thing to do is to just sign in with your GitHub ID. Once you log in, you can install the app on your organization and give access to the repositories. So here I've already done all of that. If you want to run the PatchWork CLI with our own key, you can generate a key from this and then put that in. So instead of using the OpenAI key, you can use our key. We have very generous limits, so you will be able to run, almost 50 patch flows per month using the key before you hit the limit. So you can try out everything. So now what I'll do is very quickly, I'll just show you the same example that we did first through the app, just to give you a sense of how it works. So this is the example Python repository. It's within my own uh, organization on GitHub. And what you can do is you can just choose patch, and here you can choose the patch flow. So these are the default patch flows that we have. So autofix, dependency upgrade, generate, readme, and PR review. And you can run them directly from the app. You can choose which branch you want to run it. And then, uh, so you can also provide results from your own scanner for because this fixes vulnerability, right? And then you then click patch and it'll run the flow, very similar to what we did. So let me just quickly do it here, right? And say, okay, successfully triggered the patch request. Now, in this case, uh, the patching will run our own infrastructure, and once the request is finished, it will actually create a pull request, and then you can go back and resolve it. So let me just give it a second to run. So you'll see that it's still running, and once it is finished, you will actually see the pull request, very similar to how you saw during the CLI. So I'll just keep it running. Just give it a second or two to finish. Okay, as it runs, let me just show you a little bit more about the things that you can do. So from uh, the app, you can actually choose the repository. So once you set up it on your org, you'll be able to see all your repos here. So these are all the repositories from my GitHub org. And you can choose the ones which you want by and add them to the apps for scanning or patching. So for example, so these are the repos which I have. So maybe if I add this. So you'll say they successfully added this repository, and then it will be available in your list of repositories to work on, right? From here, right? Um, the You can also filter based on private and public repos you have, and if you have a large list like I do, you can always search. So you'll see that. So this is the repo we've been working on, which is available here. It still seems to be running. So we'll come to it in a second. What I'll do more importantly on the app is that you can also create your own patch flows. So these are the ones which are provided by default, the ones that I just showed you and we ran, and all the default configurations for those. But what you can do using the app is you can also create your own custom patch flows, right? So you just go to add here, and they will be dropped down into this kind of a flow builder interface. So every patch flow will have some beginning and end, and these are the set of steps that you can use them to build your flow. So what we'll do today here for this demo is we'll try and recreate the autofix patch flow that we have as one of our default flows just to see how easily we can build and do it, right? So the first step for autofix is to figure out what are the vulnerabilities, right? And in order to discover that, you need to run some tools. So in this thing, you go here to scanning, and you say that we have two tools which are supported. And for code scanning, we'll just use semgrep. So I'll just click here, and you'll notice that semgrep has been added, right? And there are some uh, inputs that are there. So if you do not want to use semgrep, you want to use another tool, as long as you have a sarif file output, you can actually upload it here. So and then it will just work as it is. If you want to pass some custom arguments to semgrep, you can actually set it up here, right? So this is kind of all the inputs and outputs that this step takes. So once we run this scan, we'll get some results. We want to extract vulnerable code. So we'll just use this step here, which extracts vulnerable code. Again, you see that you have those default parameters that you can set. Maybe we'll set our vulnerability limit to 10 so that we just try and attempt and fix the first 10 vulnerabilities. We can also set context size. By default, it's 1000. We'll just leave it as it is. Once we have extracted the vulnerable code, now we have to fix it by preparing the right prompt. So you go here, you'll notice there is a prepare prompt, then we call the LLM, and then we extract the model responses. So you'll notice when you come to prepare prompt, is that it asks you for a prompt template file, right? Now, this is where you would actually pass on the JSON file, which I just showed, which has the actual text of the prompt, which is used to prompt the LLM and generate a fix. So because we are trying to recreate the autofix workflow, we'll just use the existing prompt file, which I have for this workflow. So I'll just go here, configs, AI. I'll just use this prompt file, right? And this is the ID of the prompt. So in this file, I think it was fixed prompt as we saw. So once you save this and come back here, you'll notice that this is again green, right? So as the connections are made and the steps are validated, they become green. So, right. So now we'll see that for the call LM, there is a number of inputs that you can choose. And I mentioned, you can choose your own key, you can add your patch key and so on. But more importantly, you can actually choose the model. So in this case, what we'll do is we'll just use GPT 3.5 Turbo, which is also a default model uh, in the app. So we'll just choose that. And once I do this and I come back here, I think this will become green, right? Okay. So So we come down to the step on extracting model responses. So here, one thing to note is that the output of the LLM that comes in has to be parsed into various fields, right? So, and we use this notion of response partitions to do that. So we we could use JSON, but it was not very reliable for the kind of changes and things that we were making. So we, instead of that, we just use strings which tell from the response what are the parts which would go to various fields. So I'll just very quickly show you how it looks like. So for example, in this particular case, the output, the way we prompt it would actually have all of these fields. And what we'll do is we'll just try and convert it into this using response partitions. So let me just paste it here, right? So how, why these particular fields? Because that is what we have put in our prompt. So if I show you very quickly the configuration that we've been using, prompt, so depending on how you prompt the model, you will have to change the response partition. Sorry, I was looking for word wrap. Yeah. So the prompt that we gave in the prompt template is something like this. And what you'll notice is that it is a complex prompt. And at the end, what we ask the model to do is we ask it to do a number of things. But eventually, we ask that, hey, please make sure that the response is always in this format. And the format is this. First, you give a commit message, then you have a change summary, then you give a compatibility risk, and finally you give the actual fixed code, right? So the output of the model will always follow this prompt, and the response partitioning is how we'll change or extract the right relevant bits. So we'll find the commit message between this string and this string. We'll find the patch message between this string and this string, right? So like most of these models do come with JSON output, and we are just trying to convert the plain text into JSON. But what we found in our own experiments, at least with the autofix, is that having a JSON output was not very reliable. So you run the same model on same input number of times, and it would just change the output will just keep changing if you use the JSON mode. So instead, by default, we rely on these partitions where the output is a plain text, and you extract the relevant bits by specifying the partitions and then doing the extracting the response from the model. So this once we put this, so we have the model response. Now, so we are trying to fix some vulnerabilities. So we need to do some code transformation. We need to change the, we have to fix the code. So you can just click modify code. Once we have modified the code, we want to make commit to the repository. So you click commit changes. You go here, you'll see as we keep adding that the required inputs for each step, if they can be pre-filled from the output of the previous step, they're automatically filled. So all of these are actually lined up properly, right? So this one as well, right? Now, once we commit the changes, we can prepare the pull request. Notice here, right? And then we can create the, sorry, create the pull request, right? And this would be the last step. So then we can join it with end. Okay. So what you'll see is with this, we have kind of recreated the autofix patch flow. We can give it some name. So let me just give it patch flow 2. And then you can actually choose what inputs you want to select. So in this particular case, maybe we allow branch selection, which will allow users to choose while calling this patch flow, which branch you want it to run on. Depending on the patch flow, for example, PR review, we might allow PR selection. So you can choose. So instead of typing the URL, you can just choose because we are connected to your GitHub app and via GitHub app, and we can show you all the existing PRs or we can show you all the existing branches. So once I do this, I'm just going to save it. And you'll see that it says, hey, patchwork has been saved. And so now there are two things. One is you can actually design and create your patch flow and export it so that you can run it locally in your own CLI, just like you run the existing patchwork patch flows, right? So you build this in, and then when you click export, it is going to export a Python file, which is going to which is going to which is something that you can run in your workflow. So I think there's some error. I'll try exporting it again. Um, okay. Uh, what I'll do is, I think I made some error in one of the steps. What I'll do is I'll use the one which I had already created just to show you how the exported code looks like. So you see that it's exported this file, and if you open it, you'll notice that it has converted this flowchart into an actual running patchwork flow, just like the existing patchwork. So you'll notice that it's a step, there are some inputs, there are some outputs, and then there is a series. So this is auto-generated code, right? Now this particular code you can then put into your um, repository in the same way like you've been doing, and you can run it locally by just calling the name of the patch flow, right? So you can just do that to execute it locally. But more importantly, once you have saved it, you can go back to the app and you can also run it within the app. So this is the one which we had just run last using the UI, the default autofix flow, and then you can see it created a pull request in this branch, right? So which is very similar to what we saw when we ran from the CLI. Now let's try and run the patch flow we just created using the app. So if you go here, you'll notice that it will appear as one of the patch flows here, and then you just click patch, right? And then it will just trigger this patch flow. So everything else is the same, just like a default patch flow. It's going to execute, run, create a pull request, and then we'll be able to uh, view the pull request. I'll just give it a second to finish. Okay, so you can see that it ran this custom patch flow. It just finished, and then it created a pull request. And then if we go here, we'll notice that it's a very same pull request because we ran a very similar patch flow to fix vulnerability. And then you'll notice that it has actually gone ahead and fixed this vulnerability, right? So that's pretty much it. I think we're coming around at 10:45. So what I'll do is I'll just go back to this. Right, so that's patchwork and that's the patch flow. Hopefully you found this relevant, and I would really, really encourage you to go back, scan the QR code, get to the repo, start it, and try it out yourself. Also, do try the app and let us know if you have any questions.